Hello everyone! Today I'm going to show you how you can build your own custom packages for your Unity projects. First of all, you have to make your own folder when you want to develop this project. Here I have created a folder called dummy package, and I have created a file called package.json, in which we are going to fill some fields necessary for our custom package. First of all, we're going to give it a name. Usually the convention for this name is usually com followed by the name of your company, or you can use your own usernames, whatever you want, and then the name of your package. The attribute display name is the name that is going to be displayed in the Unity editor when you do the importing. Then you have, of course, the version of your package in case you want to improve or make updates in the future. The Unity field is going to describe up to what version it is supported. In this case, this package is supported only in versions of Unity 2019.1 or superior. It will not work on versions from 2018 or before. Then you have the field description, where you want to write a description of what your package do. In this case, we're going just to write it's a dummy package that it doesn't do much, really. It's not really special. And then we have keywords and category. It's two different fields that probably they use for searching purposes, but they're not really important this time. And then we have the field dependencies, which we will get to it later on. For now, let's leave it empty. Now that our package.json looks good, let's go to Unity. I have created here a dummy project, which right now doesn't have much, it's pretty empty, but I want to show you the package manager. Here you have most of the packages that come usually with Unity. If I click, for example, at post-processing, you will see here the name com.unity.postprocessing, the description, the version, and in which versions of Unity does it work. So now we're going to install our own custom package. To do this, we're going to go here and click on this plus sign, and we're going to select Add Package from Disk. In here, we will look for our package. In this case, this is the root where it is stored. And we will click Open. And you will notice that inside the list of packages that are available for Unity, our package has been included. It uses our display name, it uses our description, our version, and all the kinds of attributes that we have to find in package.json. So just like that, we have already added our package. Yes, it doesn't do anything right now, but it's already added. Now let's see how to use it inside the project to maybe give some functionality to our components or objects in the project. Now let's start writing the code for our package code. First, I'm going to create a new folder. I'm going to call it runtime, and I'm going to add a new file, which I'm going to call it jumper.cs. I'm going to make a file that just makes the game object of the component to start jumping upwards. Just something simple so that we can illustrate how packages work. I have already go beforehand and I have written the code for this. It's really simple. It's just a jumper component which has a jump force, which is the attribute which holds the information of how high will be the jump done. And then we'll have a rigid body 2D. In the start method, I'm going to pick up this rigid body component, and in the update method, I'm going to check every time that the space key is pressed. And if the space key is pressed, I'm going to add a force to the rigid body vertically with the value equals to the attribute jump force. Simple as that. Okay, now the code of our package is complete. So let's go back to our Unity project. Here in the Unity editor, we see a message now in the console that says jumper.cs will not be compiled because it exists outside the assets folder and does not belong to any assembly definition file. This means that for every package that we write, this package needs to contain what is called an assembly definition file, which encapsulates the compilation of a certain amount of source files. So to do that, we're going to go in the project tab to packages, our package folder, and inside runtime, we're going to create a new assembly definition, which I'm going to call, following the conventions we follow so far, com.name of the company, name of our package. And I'm going to add at the end runtime, just to differentiate that we are inside the runtime folder. Now it's compiling again. And this time we should have not trouble at all. Exactly, now it seems like it has compiled. So here in the scene I have made two components. One is a player, which is just a cube. And then the other one is a floor, which the player is going to be standing on. And I'm going to try to make the cube to jump up every time I press the spacebar. So I'm going to select the player game object and I'm going to look for my jumper code component. See, and here we have the code of the component of the package that we just added. So now let's press play and let's see if it works. Yeah, seems like it works. Every time I press space, my player jumps. Very nice. If I change the jump force, it should as well change. Very good. And like this, we have built a package that can be used in many different Unity projects to add some functionality the same way that we use other packages, like for instance, Cinema Machine or Ads or 2D Sprite. We can use it in any kind of Unity project we want. Okay, now let's take things up a level. Let's say that, for instance, in your player component game object, in the jumper component, you want to make a custom editor. To make this, let's go back to our code editor and let's create a new folder. I'm going to call it editor because all the code for a custom editor must be inside a folder called editor. It's a Unity convention. And in here I'm going to make a new file called jumper-editor.cs. I have prepared beforehand the code for this editor. I'm going to paste it. I'm not going to explain it because this video is not really about explaining how custom editors for Unity work. I'm just going to tell you that you should see pretty much the same except for a label field with a small text that you can read in here. So now that the file is created, let's go back to Unity and we get again the same message because this file, jumper editor, is outside assets and it does not have its own assemble definition file. It will not be compiled. So let's go to editor and create its own assemble definition. I'm gonna call it com.acme.mydummypackage.editor, just to differentiate it from the other one. And now it's compiling. Let's go back to the editor to see the contents of this file. As you see, it's very simple. It just has a name, but it's not going to work for a reason, because Jumper Editor and Jumper are inside different assembly files. Jumper Editor is not going to be able to access the Jumper file, which it needs. So what we are going to do here is to add a reference to the runtime assembly file. To do this, we're going to add a new references attribute, which has an array of all the assemble files, that assemble definition files, that the code inside this one depends on. In this case, let's go check the name of this assemble file. In here we can see the name is com.acme.mydummypackage. I'm going to add runtime just to make it consistent with the file name. It doesn't really matter what the name is, but I'm going to keep it like this. So now, going back to the editor assemble definition file, I'm going to add as a reference the name of the runtime assemble definition file. So now I save and go back to Unity. It's again compiling. Let's see what happens. Okay, let's clear the console, go to player, and it's not working. And that might be because sometimes, for some reason for me, Unity does not want to properly recompile just because I added an assemble definition, not because I modified the assemble definition. So I'm going to just add an empty line to see if it recompiles once more, and this time it does manage to compile the component editor. So let's again check player, and now you can see what a nice custom editor. Now you have created in your package as well a custom editor. And you may be asking yourself, well, why have we created two different assemble files for the editor and for the runtime? We could have pack them all both together inside the same assemble definition file. Well, there is a reason for that, and I'm going to show you. Let's go to our Unity project. Now, instead of just pressing play and see how the game works inside the editor, we're going to try to build our project. So I'm going to go to File, Build and Run. And you will see that we get some error messages about jumper editor. The space editor could not be found. Well, what's the reason for this? The reason is following. When you build your project, the library Unity editor is not included. That means that if you try to compile the jumper editor, you will get an error. But you should not be actually compiling the jumper editor in the first place for your build, because, well, the jumper editor is just useful inside the Unity editor. Once you have a production build or development build or whatever kind of build, the editor code is useless. So how do we fix this? To fix this, we're going to go back to our Unity editor, and we're going to go to our package folder, editor folder, and we're going to select the assembly file. And here you can see that in the area called platforms, we are building this code for any platform, where this is not really true. You just want to use this code inside the editor. So to do that, we're going to just uncheck every single option, and we're going to check just the option editor. This will make that this assembly file will only be compiled when being used inside the editor. To show this, I'm going to apply the changes. Just for the sake of it, let's go to the code editor and see how this has changed. If you see inside the assembly definition file, you will see that now you have a field called include platforms. And inside that array, you can see editor. This kind of code is what makes sure that this assembly definition will only be used inside the editor and not on the build. Now let's go back again to the build process. I'm going to make build and run. And this time it's building without any problem. Here we have the build of our project, and it's working without any issue. Hooray! Last thing I want to talk about is dependencies. As you know, Unity comes with a lot of packages, and many of these packages could also be used inside our custom package. Let's say, for instance, that we want to use the ads package inside our custom package. How can we do this? Well, first of all, we're going to see the name of the package and the version that we want to use. And now we will go to our custom package and we're going to open the file package.json. And in here we're going to add all the package dependencies that our custom package has. In this case, I'm going to add com.unity.adds and I'm going to require the version 2.0.8. I'm going to save this and now I'm going to go back to Unity. And now it's again recompiling, and now it has detected that there is a dependency for my package to use adds. So right now, bam, you see, it has been automatically added. This means that when you use your custom packages in your projects, you do not have to worry that the user, the developer that is using your custom packages has to know actively which dependencies your package uses. Importing your custom package will, by itself, re-import all the other packages that are used for it. This is everything that I have learned so far about custom packages. I hope you liked it and it will help you. Bye!